Okay, let's start my presentation. So I'm a Yuria. I'm a software engineer from DMM.com in Japan. So today, I talk about selecting TiDB Cloud for DMM Microservices platform. This is an agenda. I introduce DMM.com LLC and Microservices platform in DMM. And I explain our plan to migrate Microservices platform from on-premise to cloud. In this presentation, I will mainly talk about migration of authentication API and authorization API for our microservices. I will talk it about later. So I first explain what kind of APIs authentication API and authorization APIs are, and then I explain the reasons to select TiDB Cloud, requirements to select database, how we verify TiDB Cloud, and I explain our status to migrate on-premises databases to TiDB Cloud. This is introduction. DMM.com is a large business company with 60 plus businesses in Japan. Our businesses are video streaming, ebook platform, online English learning, online game, forex market, cryptocurrency exchange, 3D printing, anime, a lot of businesses. We are developing a platform to provide functions commonly used by the products of each DMM businesses. The platform is called DMM Platform. These functions are mainly authentication, authorization, payment, membership, reward point, and customer support. So DMM Platform is composed of 50 plus microservices with API gateway. Let me talk about how we use DMM Platform. First, DMM products send requests to API gateway. API gateway receives a request from the client. After that, API gateway sends request to authorization API to verify the request. The request contains token for authorization information and URL of proxy destination. Authorization API verifies the token is valid or not, and token has grants to access proxy destination. For example, the request is OK to proxy to payment microservices, but not OK to proxy to membership microservices, like that. After that, API gateway proxies the request to microservices in DMM platform. I explained the motivation why we are migrating on-premises databases to TiDB Cloud. The reason is we are migrating DMM platform from on-premise to cloud. I explain it in more detail. We have a problem about when changing infrastructures. Application teams have to ask an infrastructure team to change infrastructures. It makes application teams often wait for an infrastructure team to do the work. The application teams makes documents for the infrastructure team or make meeting with the infrastructure team as needed. So as a solutions, we have a technical strategy to use cloud rather than on-premise. We are migrating DMM platform from on-premise to cloud. We expect cloud, especially fully managed services, enables application engineers to manage infrastructure without the support of the infrastructure team. It saves time waiting for infrastructure changes, and it also makes application teams not need to communicate with an infrastructure team about how to change infrastructures. It reduces the communications and meetings. Next, I explain authentication API and authorization API. So we are migrating these APIs from on-premise to cloud. These APIs are running on-premises servers. I explain what kind of resources we are using. Authentication APIs is written by Java and uses MySQL, Cassandra, and Couchbase. Authorization API is written by PHP and uses MySQL and Redis. I introduced why we use multiple databases. We had stored all of authentication information in MySQL now. As the member of DMM membership increases, it was not easy to handle some workloads. So we selected NoSQL, which has the advantage of high scalability. I explain why to use Couchbase. When we investigated NoSQL, there was a little information about NoSQL in Japan. So we selected Couchbase because Couchbase was the most popular NoSQL database at the time. So we have no special reason to select Couchbase. We migrated highly loaded tables from MySQL to Couchbase. Next, I explain why we had used it and selected Cassandra. We had operated Couchbase for a few years. We had faced with two important problems. One is the latency to search records from Couchbase increased. So when the number of records in the table exceeds a certain number, in our workload, about 1 million records. The other is Couchbase was not suitable for searching records not using primary key. So we selected Cassandra to solve these problems. We just migrated tables in Couchbase that causes these problems from Couchbase to Cassandra. Next, I introduce how we migrate authentication API and authorization API to cloud. We have two problems for migration. One is these application calls are legacy. Our application engineers lack knowledge about authentication API and authorization API, and the pre-release verification is not automated. So it takes time to update the application now. The other is on-premise constraints. So our application cannot access to on-premise databases through internet. Considering these problems, we decided to migrate our application to cloud with as few changes to the application code as possible. By the on-premise constraints, we could only migrate databases at the beginning. So we have 3 steps to migrate APIs to cloud. Step 1 is migrating on-premises databases to TiDB Cloud. Step 2 is migrating applications from on-premise to cloud. Step 3 is it is not migration, so rewriting and refactoring application code from Java and PHP to Go. Next is, let me talk about 8 requirements to select database for us. First one is zero downtime. Second one is capability to handle the workload of the applications. The sum of requests to authentication API and authorization API is equal to the sum of requests to the microservices in DMM Platform. Authentication API and authorization API receive the most requests in DMM. If these APIs are down, DMM products cannot use microservices in DMM Platform. It causes downtime of DMM products and financial losses. Authentication API and authorization API must handle a large volume of requests and achieve high availability. Third one is fully managed service. we application teams will operate databases without the support of the infrastructure team. But most of our application engineers have no experiences to operate databases and infrastructures. So they cannot operate on-premises databases. So we need to select fully managed services. Fourth one is accessible from on-premise and AWS and GCP. The application of authentication API and authorization API are running on-premises servers. We are going to deploy applications of authentication API and authorization API on both EKS and GKE. These applications must be able to access to the database from the three environments, on-premises, AWS, and GCP. These are three requirements for selecting a good performing database that we don't have to consider changing in near future. Suitable for the high concurrent and write intensive scenario, distribute transaction with strong consistency, records to be stored as a collection of relations. Last one is MySQL wire compatible database. We want to migrate databases as soon as possible. In our case, we estimate replacing to MySQL wire compatible database can reduce the number of modification and verification man-hours. TiDB Cloud meets these 8 requirements, so we selected TiDB Cloud. Next, I introduce how we check TiDB Cloud is OK for our applications. We verified TiDB Cloud with 4 steps: performance, cost, operation, and migration. First one is performance. We created TiDB cluster with 5 instances and 2 TiDB servers and 3 TiKV servers for high availability. We performed load tests with SQL queries used by these APIs, and we made sure TiDB Cloud can provide enough performance for the workload of our applications. Second one is cost. In case of TiDB Cloud, initial cost is high. We need to create TiDB cluster with 2 TiDB servers and 3 TiKV servers for high availability. It means we pay for at least 5 instances. For example, Cloud Spanner. Comparing the high availability configurations of TiDB Cloud and Cloud Spanner in a single cluster, Cloud Spanner is less expensive to start as a trial. It is just my opinion. Third one is operation. We investigated features of TiDB Cloud, and we estimated how many man-hours we operated databases on a regular basis. So let me talk about what kind of features we investigated. First one is ThinkUp provides an official plugin for third-party tools. For example, unofficial plugin for Terraform to manage resources in TiDB cluster. We have already made a system to manage resources in public cloud services like GCP, AWS using Terraform. So we can also manage TiDB Cloud on our system using Terraform. It makes managing resources much more easier. And then TiDB Cloud supports zero downtime operations for scale in, scale out, scale up, and version upgrades. We just operate it on GUI or make a request to ThinkUp. TiDB Cloud also supports backup and restore for records and audit logging. So we can operate TiDB Cloud as easily as other databases in public cloud services. Fourth one is migration. We checked how much we need to change application codes, SQL queries, and table schemas for migrating to TiDB Cloud. As a result, no changes in SQL queries and no changes in application code for MySQL. We just changed table schemas from auto-increment to auto-random for MySQL. Next, let me talk about status to migrate to TiDB Cloud. We have migrated databases to TiDB Cloud without downtime using a strangler fig pattern. Before migration, we modified application code for double write, and we created 3 batch processes, comparing records between on-premises databases and TiDB Cloud, fixing inconsistent records between on-premise databases and TiDB Cloud, and migrating records from on-premises databases to TiDB Cloud. I will explain it more detail later. PingCap also provides tools which make migrating databases easier. It is called TiDB tools. In case of MySQL, we use 2 TiDB tools to migrate MySQL. Sync diff inspector for comparing records stored between MySQL and TiDB Cloud. Data migration tool for migrating records from MySQL to TiDB Cloud. Next, I talk about how to migrate databases more detail. So first step, we created a TiDB cluster in TiDB Cloud, and we run both on-premises databases and TiDB Cloud. Next, we export records from on-premises databases and import them into TiDB Cloud. And then, so we modify application code to write records to both databases, on-premises databases, and TiDB Cloud. It is a double write. The application first writes a record to on-premises databases and then to TiDB Cloud. If it is a transaction, if an application fails to write records to on-premises databases transaction is rolled back. If an application fails to write records to TiDB Cloud, both transactions, on-premises databases and TiDB Cloud are rolled back. And then we run batch processing to compare records between on-premises databases and TiDB Cloud. If the record doesn't match exactly, batch processing would fix them. After that, we changed the read reference from on-premises databases to TiDB Cloud. We continue use batch processing until the records between on-premises databases and TiDB Cloud match exactly. And then we stop writing records to on-premises databases, and we also stop running batch processing. That's it. This is our procedure to migrate TiDB Cloud. I talk about problems while migrating to TiDB Cloud, but it is small problems. TiDB Cloud often released updates with important features. We just checked for TiDB Cloud updates, but we didn't check for TiDB updates. So we faced with 2 problems while migrating to TiDB Cloud. One is TiDB Cloud started supporting foreign key constraints. When we wrote design doc, we did not consider supporting foreign key constraint. So after the TiDB Cloud updates, we rewrote table schemas and how to migrate to TiDB Cloud in design doc. The other is TiDB Cloud starts supporting session manager. we faced with two problems. One is TLS connection. When we deployed Session Manager, TiDB Cloud with Session Manager didn't officially support TLS connection. So we need to communicate with PinCap to change our configuration of TiDB Cloud to support TLS connection from the client. The other is deployment for Session Manager. After the TiDB Cloud updates, we could select to deploy Session Manager to placement driver or EKS. But we had already created TiDB cluster with Session Manager deployed on placement driver. So we considering the update, we migrated Session Manager. We needed to migrate Session Manager in TiDB cluster from placement driver to EKS. So it is my opinion. I think the application engineers need to pay more attention to the updates of TiDB and TiDB Cloud than other fully managed databases in public cloud services. This is our status to migrate to TiDB Cloud. That's all my presentation. Thank you.